Now, the last question on the basic integrals is on revision 6, which is on volume integral. So here we'll only do a problem on Cartesian coordinate system because this was basic integrals. At least you have an idea of line integral. In Mathematics 1B, we just do the basic integrals like you need to have an idea on line integral, surface integral, and volume integral. So this is our last one. Basic means we will maintain a Cartesian coordinate system. So proceed. So evaluate the following triple integral over the rectangular box V defined by the limits. So the first thing, we must know that in our Cartesian coordinate system, dv is simply d inside out. So dx, dy, and dz. So that is what we know for dv. dx, dy, and dz. So if you're told to integrate this, then this is simply integrating inside out. So this will be our z, this will be our y, this will be our x of x, y, z, dx, dy, dz. Inside out. Z is out, followed by y, followed by x, and then followed by y, then finally x, inside out. So our range, we can put them. For z, we have 0 to 3. For y, we have 0 to 1. And for x, we have 0 to 2. Then you have x, y, z, then dx, dy, dz. So we are going to integrate inside out. That is from dx, then dy, and then dz. Okay. So what are we going to have? The first case. So we start with x. So int with respect to x, our first one, inside out. So int with respect to x. Now what are we going to have? We have 0 to 2, x, y, z, dx. When you work this out, you have 0 to 2. No, you're integrating straightforward. So when you integrate this with respect to x, x is there. So we simply have x power 1 plus 1, so that is power 2, divided by 2, then y, z, substituting from 0 to 2. Remember, c will cancel out, so I don't need to do that. Maybe for completeness, let me just have it. So plus c, then substituting from 0 to 2. When you do the substitution, for the upper bound, you'll have 2 squared over 2 y, z, plus c, then minus the lower bound, 0 squared over 2. Let me just make it easier. For the lower bound, we have 0 for the first case, and y, c, 0 times everything becomes 0, then plus c. Now when you work this out, you find that we remain with 2 squared is 4, so it is going to be 2 y, z, then c cancels because you subtract. That is our first step. Now the next, we go to y. So int aggregate with respect to y. Remember, inside out. So y was ranging from, let me check, from the second one, the inside one is 0 to 2, done, 0 to 1. So y is 0 to 1. And now we have 2y, z, dy. Now again, you check only y. So we have 2y squared over 2, then z, then plus c, then substituting 0 to 1. Now substitute the higher bound because this 2 will cancel this. So we have 1 squared z plus c, then minus the lower bound 0 plus c, because we are substituting 0, c cancels, and the answer here become z. Now we will go to the outer, the last one. So integrating with respect to z. Now when we do the outer one, we have integrating. The range is 0 to 3 for the outer integral. So 0 to 3 z dz. Now this is z squared over 2 plus c, then 0 to 3. Substitute the upper bound, 3 squared over 2 plus c, then minus the lower bound will have minus into bracket 0 plus c. Again, c will cancel. If that happens, we are going to have 9 over 2. If you like, 4.5. That is how we are going to solve that. Okay, so that is the answer for volume integral. Remember, this is basic. We are only dealing with the Cartesian coordinate system. When it is spherical coordinate system, it's different. Even in the surface integral, we left the circle. We just deal with the rectangle, which means we just consider the Cartesian coordinate system again. Now we have another question here. To solve and finished. Same thing, dv in Cartesian coordinate system is dx, dy, dz. So inside out. So we are going to have for z 0 to 3, for y 0 to 2, for x 0 to 1. I think so, 0 to 3, 0 to 1. Then we are integrating x, y squared plus z squared dx, dy, dz. We're going to perform the same thing. Inside out, we start with x. So 0 to 1, our integral is x, y squared plus z squared dx. That's our first move. Now x will be x squared, y remain y squared, we don't touch it, but over 2. Plus, there is x next to z here, so it will be x power 1 when you add 0 to 1, now z squared, and then this plus c, and then substituting 0 to 1. Then what do we have? On the upper bound, we have 1 for x, so 1 squared y squared over 2 plus 1 z squared plus c minus 0, because where you put x 0, so it is 0 plus c. Now c cancels again here, and we are going to have our solution as y squared over 2 plus z squared. Good. We move on. to the middle integration, which is for y, 0 to 2. So we have 0 to 2. Now y squared over 2 plus z squared, now dy. Again, when you integrate where y is, this one will be y power 3 over 6, because you'll have a plus 1. Okay, let me make it clear with you. There, it's clear for you. So plus 1, then 2 plus 1. So you see, we are going to have x, which is 3 times 2, which is 6. Then plus, I hope you know what is happening. There is y here, raised to power 0. We add 1, we divide by 1. When we do that, we get z, y, plus c. And this one is from 0 to 2. When you substitute the upper bound, you have 2 cubed over 6 plus z, because y is 2, so plus 2z. Y is 2 plus c. When you substitute the lower bound, substituting the first case is 0, you add again 0, so plus c, c will cancel. Now that we are going to have 2 cubed is 8 over 6 plus 2z, 8 over 6 plus 2z, which you can simplify as 4 over 3 plus 2z. Now the last p is the outer one, which is for z. Now z, the range is from 0 to 3. That's our last integration. So 0 to 3. And we are integrating 4 over 3 plus 2z are close, and now dz. So the first part, we have z power 0 here, written, not written, so plus 1 over 1, then here plus 1, 1 plus 1 over 1 plus 1. When you play around that, you get 4 over 3 z plus 2 z squared over 2 plus c, then integrating from 0 to 3, which will be the upper bound. Remember, this cancel this, so the outer bound will have 4 over 3 dot 3, and then plus 3 squared. Close the bracket, sorry, we have plus c, so plus c, close the bracket, minus 0 plus c. When you do that, we have the final answer here is going to be 4 times 3 times 3 is just 4, plus 3 squared is 9. C cancels, and the answer, let's see, we have 4 times 3, okay. Okay, let me see if all is well. We just move very fast, but I think everything is fine. So the first integration with respect to x, 0 to 1. Here we have x squared over 2. X is power 1, yes, then y squared, then plus x z squared plus c. Now we have y squared because x is 1, so y squared over 2 plus z here we have x is 1, so it is z squared. Okay, now we go to y. When you integrate with respect to y, I think this is where I think I have, yeah, that's why it's good to counter check. This is z squared, so I needed to bring it here. Z squared, z squared, z squared z squared. Fantastic. So that means it changes the maths here. And also, yeah, so let me just wrap this. Let's go to counter check so that because we use this, we don't need wrong thing. So for z, then this one will be z already is power 2, so it is power 2, then power 2. So I'm going to have 4 over 3 plus z power 3. So I'm going to have 2 over 3 z cubed plus c. Substituting will be 4 over 3 dot 3, which is z plus 2 over 3 dot 3 cube, then plus, okay, c is missing. So we'll have 3 cube plus c minus into bracket 0 plus c. That cancel. Now what we have is 4 plus, this is going to be here 1. Here we have 27. So 3 there 1, 3 into 27, 9. 9 times 2, 18. So plus 18. The answer is going to be 22. Let me counter check again. All is well. 0, 3. We start with the inner one, xy squared plus z squared. That's fine. Okay. Okay. I think I'm okay. Unless otherwise. And that's all for basic integrals. From line integrals, we started from line integral. Okay, we started here. From line integral to surface integral, this is basic. And then to volume integral, so basic. Remember, we can go deep, but not now, since this is Mathematics 1B. You just introduce to integrals, and that is the end.